In today's lesson, we are going to look at appreciation. So this is going to branch off a bit from what we've looked at in the past, and we're going to be starting to look at some financial situations that show appreciation. It is going to tie into a little bit of our patterns in our relationships, but with more of a practical application. So again, by the end of this, hopefully you're able to identify financial situations that show appreciation, and then you're also able to identify how values of things change over time by calculating the appreciation amount and appreciation percentage. So I want you to take a second to look at this picture here, or this image, and just write down things or just make note of what do you notice and what do you wonder. Right, so just take some time to think about what do you notice and what do you wonder about this image here. Right. Some things you may notice or think about, maybe you have no idea what these are. Right? So one of your things that you wonder is, what are they? Another thing is, maybe you notice that they're collectibles, or you think, are they collectibles? Who collects them? Which one is worth the most? Right? Where are these characters from? Are all of these kind of toys or figurines just as expensive? What year were they created? What makes some characters more expensive than others? Right? So there's many different things that you could come up with, and it doesn't have to be math related, right? The idea is just to think, look at the picture and just kind of think about things or come up with questions related to it. So like I said before, what we're looking at today is appreciation. And appreciation, that by definition, is an asset, is an item, one of the things we're looking at first is what we consider an asset. Right? So appreciation is going to be something that assets do, and the image that we just saw about the little Funko Pops, those are what we call assets. And assets are an item that you own that has value. So the key thing here is that it has value. Right? So an asset is an item that you own that has value. So why do you think some assets increase in value over time? Right? So again, generally speaking, anything that you own probably has some sort of value, but you might think about some things increase in value over time and some things probably don't increase over time. So why do you think some assets increase in value over time? Some things you may come up with could be something like the demand is greater than the supply, right? So you may have heard the term supply and demand before, right? So if a lot of people are trying to get one item, maybe it's a limited edition, right? You see shoes that are like that. You see some figurines or maybe cards or things like that are limited edition, right? And a lot of people want them, but there's only so many made. So that could cause the value to increase over time. Another thing that may cause assets to increase over time is just in general inflation. Just the actual idea that the actual cost of everything in general increases over time. Right? If you ask your parents how much they paid for something when they were younger, it probably differs from what you pay for it now. Right? You look at houses, you look at phones, you look at toys, anything like that. You can see that there is inflation, so prices go up over time in general. So again, the main topic is appreciation. So appreciation is the idea that there is the increase in value of an investment, right? So appreciation just basically means the value of an item increases, right? So again, the asset that you own, if the value increases, that's considered appreciation. In order to benefit from appreciation, the asset must be sold. So kind of common sense there. In order to gain anything from something appreciating in value, you need to sell it. Otherwise, it's still like just you're not making any money, so it doesn't really matter, right? Kind of you might have heard the terms something may be worth a lot, but only if someone buys it, right? So you may have a hockey card that's worth or that's very expensive, but you only really benefit from that if someone's actually willing to pay that, right? You might see that a lot in like Pawn Stars, right? So people have things that they think has high value, but he's not willing to pay a lot for that. So it really doesn't matter too much unless you can find someone that's willing to pay that increase in value. So some things that can affect appreciation, we have changes in exchange rate, right? So again, looking at the US dollar is usually higher than the Canadian dollar, things like that. Increased demand for an asset, right? So maybe everyone really needs that item. You can think of when COVID started, people were selling toilet paper and water for really high prices, so they appreciated in value. Maybe it's not ethical, but there was an appreciation in value. Inflation, the steady increase in prices over time, and reduced supply of an asset. So again, if there's less of them available, chances are that the value of them is quite high. So let's think about what are some things or assets that can appreciate in value, right? What are some things that you can think of that can appreciate in value? We've already seen kind of an image of those Funko Pops, right? Because obviously you don't buy a single figurine for, I think it was like $13,000, right? They're generally about maybe $20, and the rarity of them causes them to appreciate in value. So what are some things that can appreciate in value? Right? What are some assets? Some things you might be able to think of. Maybe cars, right? Especially vintage cars. Maybe certain toys, right? If they're collectible. Might see things like coins. Sports cards tend to be a big one. They tend to be making a comeback lately. You could think of memorabilia of any sort, whether it's like sports memorabilia, band or music memorabilia, movie memorabilia. Hopefully I spelt it right. You can think of artwork, right? Certain artworks are appreciating value, especially if the artist happens to pass away. Usually the price or the value increases. We talked about houses. You can see that now. This is a case where the demand is higher than the supply. You can think of things like land, right? Just the value of having land itself, right? That the value of land has gone up and increased. You could think of jewelry, and you could think of some metals such as gold, silver, and jewels in general. Right? Generally speaking, there's only so much matter on the planet, right? So if we use up all of it, it's going to be gone. So again, it's that idea of supply and demand. So again, lots of different assets, and maybe you were able to come up with some other ones on your own. Actually, a new one that you might want to add, NFTs. Right? It's kind of that new kind of digital artwork that's very specific, right? That tends to be a new kind of emerging trend of assets, you could say. So let's look at a graph comparing kind of two different relationships in terms of values of investments. And we want to compare them and see what's the same and what's different. So we have one that's considered simple interest and one that's considered compound interest. So we want to think about, and we've kind of done this before in previous lessons, but what's the same between the two lines and what's different between the two lines? Right, so if you take a second to look at the blue and the orange line, some things that you recognize that are the same are that they both start at $10,000. So both investments are at $10,000. And they both invested for 10 years. At least what we've graphed. The difference that we see between the two of them, again, using some of the terms that we've talked about before, right? One is linear. One is nonlinear. We see that general curve for nonlinear. Blue one is in a straight line. Again, alongside that, actually let me just separate these because we can kind of be a bit more descriptive. You could say something along the lines of, because it's linear, it's increasing at a constant rate. And what's different for the other one in terms of the growth, non-constant growth. If you want to get technical, you could say something called exponential. It's exponentially getting larger, which is another type of relationship. So again, that's kind of what's the same and what's different between the two graphs or the two different investments. So using the graph, describe what you think simple interest represents. So simple interest is that blue line. So looking at that blue line, simple interest represents a constant increase of, and if we look at the values, it's increasing by $1,500 a year. So there's a constant increase, right? Because of that straight line, that linear relationship, it's increasing by a constant amount. What do you think compound interest represents? So looking at the two, right? Again, compound interest is the orange. So looking at that, what do you think compound interest represents? And again, we know that it's a nonlinear relationship. And just based on the general idea, you might say the value grows slowly. Grows slowly at first. But then increases. Right, we see that kind of slow growth and we see it start to separate, and then eventually it's increasing by quite a bit every single time. Right, you can see the rate of change is different every year, or what we're changing by every year is different. Again, using those terms that we're familiar with. Interpolate at what year compound interest becomes the better option. So if we look at this, when does the orange option become better? Right? When is it better to have compound interest? Right? Interpolation just basically means make a prediction within the graph that you have or within the data points that you have. So we can just add that as well. So I say within the data. So we have our data here. So within that, when do you think it would be better, or when does compound interest become a better option? Right? And if we look at it, we see if year 0, they're the same. Year 1, they're the same. Year 2, we can see a slight separation between them. Right? So here, compound interest is better. If we're assuming we only go year by year by year and not within that year. So compound interest is better after 2 years or around year 2. For D, use extrapolation, or using extrapolation, what would you expect the simple interest investment to be worth in year 15? So extrapolation is the opposite of interpolation, and this is the outside of our data. So this is beyond the graph that we have, beyond what our line is showing us. So if we want to use extrapolation, again, we can continue to graph our line because we know what it's going to increase by every time. Simple interest, again, is increasing by a constant amount. So 26,500. Then we have 28,000 and so on. So we can keep on increasing by 1,500 every single year till we get to year 15. And by doing that, we should find that you should have around 32,500 in year 15. What financial decisions can you make using this graph? Right? So based off of this graph, if you had the option between compound interest and simple interest, what financial decisions would you make? Right? And this may change depending on the scenario. So there may be multiple answers here, or there are multiple answers here, depending on what your situation is. So by looking at that graph, the financial decisions that you can make would be something along the lines of short-term investment, right? If you're only doing it for 1 or 2 years, not much difference. Long-term, compound interest definitely gets you more, or is the better option. Right? Because it's growing at a faster rate over time. Right? So short term, there's not much of a difference, but when you get into the long term, you can see that it's much better to have a compound interest is the better option. Example 2, comparing time impact on investments. So we're going to be looking at different times, or how does time impact your investments. So again, we're looking at a graph and we want to calculate, or sorry, not calculate, compare the two. So similar to what we've done before. So we want to figure out what is the same and what is different about these two graphs. Right? So if we look at these two graphs, the same is, and you have these little bubbles to help explain it, the same is they both invest $200 per month. So they're both putting in the same amount. They all stop at 65 years, so they're all investing till they're 65 or till when they retire, you can assume. So stop at 65 years. And you can assume compound interest is being used because of the nonlinear graph. So we can assume there's compound interest being used because it's nonlinear. If it was simple interest, it would just be a straight line. What's the difference between these different lines, or these different people? Well, they start investing at different ages. Right, we can see one starting at 25, one at 35, and one at 45. By reading the blurbs, each person contributes a different total. And, or I guess not and, they have different final investments values. and you could say that they've earned different interest amounts. So basically they're still putting the same $200 in per month, but we can see that the person who started off earlier, or Jack, is earning more interest, or more value is added over time because he ends up quite a bit higher. So we can say different interest amounts. So we had a little bit harder here because we had to understand a few things about what was going on, but hopefully you kind of got these two ideas. What types of interest are these graphs modeling? Well, again, we've talked about compound interest because it's nonlinear. We have talked about exponential a little bit, which is a term for some nonlinear graphs that curve or have this curve. What financial decisions can you make using this graph? Well, based off of it, right? Again, the main one that we've talked about before, invest with compound interest. And the other one is start investing early. Right? Because you see there's quite a difference if you start earlier compared to later. So if you have the option, just try to invest or at least save money as early as possible because it will build up over time, especially if you are using compound interest. In our last example, we're going to look at exchange rate appreciation. So we talked about looking at the Canadian to US dollar, kind of being the idea of appreciation, the value of money increasing when you're making that exchange, or the value increasing. So how do you know this graph is modeling appreciation? Right, looking at the value or the exchange rate from Canadian to US dollar. So basically what this means, in January, 1 Canadian dollar was worth 78 cents American, right? And 78.2 cents. Then 78 cents, 79, 79.6, 81.5, and finally 83.1 cents for every Canadian dollar. How do you know this graph is modeling appreciation? So how do you know that we're seeing appreciation? And again, if you go back to the definition of appreciation, it means the value is increasing. So we see here the trend of the graph is increasing over time. Right, so we can see that our graph is increasing over time. Right, it may not be linear or maybe not quite non-linear, but we do see it increasing over time. So that's enough to say we're talking about appreciation. What factors could have caused the Canadian exchange rate to increase? So what factors do you think could have caused the value of a Canadian dollar to increase over the span of January 2021 to June of 2021? So you have to keep in mind that this is kind of over the pandemic. Right? So what factors could have caused our exchange rate to increase? Right? Or the value of the Canadian dollar to increase? Right? You could think about the economy opening up. Right? So when stores started to reopen, or online shopping, if you can, a lot of people prefer to online shop. And so if more stores were offering that, maybe you decided to shop more. I know I can say that I was a victim of that. Being able to online shop caused you to kind of buy more. You could also think that we were spending money in Canada. So when that money kind of gets brought back into the country or stays in the country, then it increases the value of it. and no one's allowed to leave due to the travel restrictions. So again, spending money in Canada could have been another factor that caused that. So we want to look at starting to calculate the appreciation value from January to June. So to figure that out, we have a formula where appreciation is equal to the end rate minus the start rate, or basically the end value minus the start value. Right, so you could say value as well, depending on what you're looking at. Here we're looking at rate for exchange, so we'll use rate. But either way, we take the end value, or the end rate, which was $0.831, or 83.1 cents, minus the initial, or the start, which was 78.2 cents. So basically we get an appreciation, or an increase, of 4.9 cents, or $0.049. To calculate the January to June appreciation value as a percentage of the January rate, so basically see what percent did we increase from January to June, we want to calculate a percentage. So kind of like finding like a test score almost, or an average. We find the end rate minus the start rate, which we have done, or we did already. So the 0.831 minus 0.782 divided by the start rate, and then we're going to take that first and multiply it by 100. So we're going to figure this out first and then multiply it by 100. When we do this calculation and divide, we should get 0.063 times 100. So we get 6.3%. So here we could say, therefore, the exchange rate appreciated in value by 6.3% from January to June. So again, just changing it to a percent, because the value of appreciation may not really make a lot of sense when you're actually going through it, or when you're actually looking at it. But when you say it increases by 6.3%, that tends to be a little bit more tangible, and allows you to visualize it a little bit more when you're actually thinking about it. So again, the main thing from this lesson is just understanding what appreciation means, how we can actually calculate the percent appreciation given certain values of assets, understanding what an asset is, how an asset might appreciate in value under what conditions, as well as figuring out or the difference between compound and simple interest, at least at a basic level. Just understanding what types of relationships they represent and kind of what they mean in terms of values increasing and investing.